Yeah, then comes this question. It says the concentration versus time graph below is for this equilibrium. Okay. The changes at T1 and T2 are due to temperature. This is T1 and this is T2. Okay. Then the question says, for the time T1, this one, state what happens to, they want you to write increase, decrease, or remain the same. Happening to what? Rate of reaction. Okay. How do we know what happens to the rate of reaction? Okay, to know this one, you need to know whether temperature increased or temperature decreased. Increase in temperature increases rate of reaction, and the decrease in temperature decreases rate of reaction. That's all we need to know. So how do we tell whether there is increase or decrease of temperature? You rewrite the equilibrium. It is 2SO2 plus oxygen, giving you 2SO3, enthalpy change less than 0. What do you do? You represent what happens here. X is sulfur dioxide, and it increased. And O, oxygen, also increased. We are seeing it here. Meanwhile, Y is sulfur trioxide, it decreased. What does that mean? That now we know the position of the equilibrium. It is from low to high, so that is it. It is reverse. After that, what do? You come to our enthalpy change. What you have here is for the forward. And enthalpy change less than 0 is exothermic, so which means that forward is exo and reverse is endo. But we have seen that our equilibrium is reverse favored and reverse is endo. Now, according to Le Chatelier, increase in temperature favors endo. So because it is endo which is favored, the conclusion is that temperature increased. And we know that increase in temperature increases rate of reaction. So what will happen to the rate of reaction? Answer is increase. Yeah, then comes here. What happens to the position of equilibrium? Here, we use the same working here. And what did we see here? Reverse is favored. And that's the answer for this one. Yeah, that is it. Yeah. Then comes this question. It says, state what happened to equilibrium constant at T1. Okay, here you need to know that when you have two kinds of reaction, endo and exo, you need to know that for endothermic reaction, increase in temperature increases Kc, and decrease in temperature decreases Kc. While for exothermic, increase in temperature decreases Kc, and decrease in temperature increases Kc. So it is very easy to tell that for endothermic, Kc follows temperature. When temperature increases, Kc increases. When temperature decreases, Kc decreases. While for exothermic, increase in temperature causes the reverse. Increase in temperature decreases Kc, and the reverse is true. Now you need to know something, that we are dealing with an exothermic reaction, so we are going to go this side. Okay? And when you go this side, what is happening at T1? Temperature is increasing, so we are going to pick this. And what is the answer? Increase in temperature decreases Kc. So the answer is going to be Kc decreases. Yeah, then comes this question. It says that for time T2, state what happens to 1. Rate of reaction. You write increase, decrease, or remain the same. How do you go about that? Okay, the best approach here is to find out whether at T2 temperature increased or decreased, because we need to know that increase in temperature increases rate of reaction, and the decrease in temperature decreases the rate of reaction. So to predict that, you need to rewrite the equilibrium, and that is it. So when you look at our equilibrium here, enthalpy change is less than 0. This is it. And after writing it, what do we do? You represent the changes here. Let us look at X. X is sulfur dioxide. It is this one. It decreased. Let's go to our oxygen. It also decreased. Let's go to our Y. Y is sulfur trioxide. It increased. And after that, then it is clear that forward is favored. How do you know it's from low to high? That's the direction. So forward is favored. After predicting the position, then you come here. You need to know that whatever you have here is for the forward. This one is enthalpy change less than 0, implying exothermic reaction. So, meaning forward is exothermic and reverse is endothermic. But you need to know that according to Le Chatelier, decrease in temperature favors exothermic, and the increase in temperature favors endothermic. So let us look at here. Our position is forward favored, and forward is exothermic. So what does that mean? It means temperature decreased. And we know that decrease in temperature decreases the rate of reaction. So what is the answer here? The answer is decrease. Yeah, then we come to this question. Yeah, state what happens to equilibrium constant. Okay, you need to know that what happened at T2, temperature decreased. And the decrease of temperature for an exothermic reaction, how does it affect case C? You need to know that for exothermic, increase in temperature decreases case C, and decrease in temperature increases case C. That is for exothermic. Let me repeat. For an exothermic reaction, when you increase temperature, case C decreases. And when you decrease temperature, case C increases. So I've just observed that at T2, temperature decreased. So what will happen to case C? Because it's an exothermic reaction, case C will increase. Yeah, that is that. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yes, don't forget to subscribe, to comment, to like, to share. And I would also want to remind you that PSSB, Physical Sciences Silver Bullet, is a YouTube science channel dedicated to physical sciences grade 12, 11 and 10, and natural sciences grade 8 and 9. Our appeal to you is that when you are using our channel, don't go to video because of the wide scope of the channel. Just go to playlist and choose the work which belongs to your level. For grade 8 and 9, each one is presented as Natural Sciences grade 8 or Natural Sciences grade 9. Just click. For grade 11 and 10, each one is presented as Physical Sciences grade 10 or Physical Sciences grade 11. As for grade 12, each chapter is presented as a tile. So don't hesitate. Visit it, click it, you'll have it. So stick with us. We believe we are the best. See you next time. Bye-bye.